Frequency of word use versus number of words. Let's consider a partition of the words in the English language according to respective use frequency. Looking at the frequency graph, it should be easy to find classes of words with approximately the same frequency. Now I'm interested in the size of these classes. I know that the size depends on the relative cutoff points, but I'm more interested in a general classification, i.e., are there more common words, or more uncommon words?
There is a well-known formula that appears to describe the frequency distribution of English words reasonably well. Zipf's law states that given some corpus of natural language utterances, the frequency of any word is inversely proportional to its rank in the frequency table. Thus the most frequent word will occur approximately twice as often as the second most frequent word, 3 times as often as the third most frequent word, etc. For example, in the Brown corpus, the word the is the most frequently occurring word, and by itself accounts for nearly 7% of all word occurrences, 69,971 out of slightly over 1 million. True to Zipf's law, the second place word of accounts for slightly over 3.5% of words, 36,411 occurrences, followed by and, 28,852. Either from actual measurements of word frequency, see, for example, Wiktionary, frequency lists, or from Zipf's law, one can deduce that most words are infrequently used. There are tens of thousands of words that taken all together are used less frequently than any of the or, of, or, and. Indeed, the most frequently used 500 words account for more than half of all usage, leaving hundreds of thousands of words used quite infrequently indeed. Zipf's law predicts that relative frequencies decrease like 1/2, 1/3, 1/4. If there are 250,000 words in the English language and their frequencies follow Zipf's law, then their relative frequencies add up to, which is about 13.01, e lane 250,000 plus gamma, where gamma is the Euler-Mascheroni constant, about 0.5772156649. Given n words in toto, if you want to find out the number of words in each of k groups with total usage the same in each of those groups, solve lane mi plus gamma equals I, lane n plus gamma slash k for I from 1 to k1. That is, mi equals xpi, lane n plus gamma slash k gamma. For example,
If you want to support the channel, please consider subscribing.